Sir, you're
Sir, you're
muted po.
unmuted.
Sorry, I've been talking along. Okay, so we have geometric sequence and geometric series. So what is the difference between arithmetic sequence that we had in our previous lesson? All right. So objectives. In this lesson, you will be able to illustrate a geometric sequence, differentiate a geometric sequence from an arithmetic sequence, differentiate a finite geometric sequence from an infinite sequence, determine the geometric means and nth term of a geometric sequence, and find the sum of the nth term of a given finite or infinite sequence. So let us try the definition. So a definition of a geometric sequence is a sequence in which each term is obtained by multiplying the preceding term by a fixed number. And that's called a geometric sequence or a geometric progression. So by this time, we are not adding nor subtracting, but we are multiplying. Or we can also divide if you want to get the difference, or they call it the common ratio. The formula for the nth term of a geometric sequence is with the first term a sub 1 and a common ratio r is given by the formula. So this is the formula that we are going to use now. A sub n equals a1, which is the first number. R is the common ratio. Now it's common ratio, right? And of course, n is the nth term. So let's try this first example. We have, again, don't forget a sub n is equal to a1 times r raised to n minus 1. Here we need a calculator, so because the powers sometimes are very big. But anyway, we have this example 1. So the nth term of a geometric sequence, write the formula of the nth term of the geometric sequence. So let us try. The first thing to do before we were looking for what? The common difference. By this time, we are looking for the common ratio, right? So imagine this is the first number, 32, and that's 8. So 32 then became 8, then became 2, then half. So what is the common ratio? So you divide the second by the first. So it will become 32 over 8. Divide the second to the first. 8 over 32. 2 over 8. 1 over 2 over 2. 1 over 8 over half. So here, the value will become 1 over 4. Or, yes, 1 over 4. Here, 2 over 8 is also 1 over 4. This is also 1 over 4. So 1 over 4. So therefore, the R is 1 over 4. It's common ratio. Or if you multiply the preceding, 32 times 1 for this 8. 8 times 1 for this 2. And so on. So write a formula of the nth term. So the formula that we have is a sub n is equal to a1 times r n minus 1. So since we're looking for the formula only, a sub n is equal to a sub 1 is 32. Multiplied by 1 over 4 n minus 1. That's it. We are looking for the formula only. If, for example, we want to get the second term, this is the 8th, or the third term, which is 2, let us try a sub 3. This is the answer that we have already. If, for example, we want to get a sub 3 only, we have 32, 1/4 of 3 raised to 3 minus 1. So 32, 1/4 raised to 2. So you have to square it first. 32 times 1/4 squared is 1 over 16. So 32 times 1 over 16, 32 divided by 16, which you will get 2. That's why the third number is 2, right? So it's easy. I think this is easier than the formula that what we had in the previous one, right? Okay, the nth term of a geometric sequence. Write the first 4 terms of the geometric sequence, which nth term is given by v4, open bracket, -5, closed bracket, raised to n minus 1. So we are going to get the first 4 terms. So we just simply substitute. Okay, so let's copy the formula. A sub n is equal to, what was it? 4, -5 raised to n minus 1. So the first 4 term, let's start with 1, a sub 1. So 4, -5 raised to 1 minus 1. So a sub 1 equals 4. That's 0. So any number raised to 0 is 1. So the first number is 4. Okay? Any number raised to 0 is 1. Next, we have a sub 2. A sub 2 is equal to 4, -5 raised to 2 minus 1. So 4, -5 raised to 1. So the answer is -20. Okay, a sub 3. A sub 3 is 4, -5 raised to 3 minus 1. So 4 raised to -5 squared. So 4 times 25, because any number raised to, any negative number raised to an even number, it's always positive. So the third number is 100. And the last, we have a sub 4. For the a sub 4, we have 4, -5 raised to 4 minus 1. So 4, -5 raised to the power of 3. So any number, any negative number raised to an odd number will result to a negative number. So we have -600, right? So that's our four numbers. 4, -20, 100, and -600. -600. Did you get it? Do you have any question? Jairus. Next, we have the next question, example. Find the 8th term of the geometric sequence 48, 24, 16, 6, and 3. So he's still copying, right? So, okay, continue copying there. So find the 8th term of, so we have a number 3, this number 1. Number 3. So we have the 8th term of this geometric sequence 48, 24, 12, 6, and 3. We are looking for the a sub 8. So we have to determine first our common ratio. Will you give me the common ratio here? Rainier, what's the common ratio? Timothy, what's the common ratio?
Sir, 1/2.
1/2, very good. So we have 1/2 because 24 divided by 48 is half, 12 divided by 24, that's R. So the a sub 8 is unknown. So R is half. So we will get the common ratio by dividing the second number to the first, third number to the second. And our a sub 1, which is 48. And the n is 8. So let's try. A sub n is equal to a1, a sub 1, rn minus 1. So what is our a sub 1? So it's given there. So a sub 8 is equal to a sub 1, which is 48. And then the r is half raised to 8 minus 1. So we have 48 raised to 1 over 2 to the power of 7. So what is 1/2 to the power of 7? So let us try. We have 1 raised to 7 is 1. And 2 raised to the power of 7 is what? If 2 raised to 5, 2 raised to 6 is 64. So therefore, 2 raised to 7 will give you 128. Right? So 64 times 2 is 128. Okay, so therefore, we have 48 over 128. So what is the common number between 48 and 128? So we can simplify that. First, we can divide by, let's make it smaller. Divide by 2 each. So 48 divided by 2 will give you 24. And 128 divided by 2 will give you 64. So there is a common number here that you can divide, which is 4. Okay. So 24 divided by 4 will give you 6. 64 divided by 4 will give you. We can also divide by 8 so that it's easier. 8. Right? So divide by 8. So 24 divided by 8, 8, so we'll give you 3 over 8. Okay? So that is the 8th number. So the 8th number is 3/8. You got it? And we have the last question. Find the first term of the geometric sequence, which fourth term is -40 and which common ratio is -2. Okay. So letter A, number 4. Find the first term of the geometric sequence. So which is the fourth term is -40. The common ratio is -2. Find the first term. So we are looking for A sub 1. Okay? So we will have the formula A sub n equals A1 Rn minus 1. So A sub n is -40 is equal to A sub 1, which is a known. The common ratio is -2. And n is 4 minus 1. So -40 is equal to A sub 1, -2 to the power of 3. So -40 equals A sub 1 times -8. Divide by -8, then cancel out. Therefore, A sub 1 will be equal to 5. So the first number is 5. And we have also which term is -11 and which, the fourth term is -11. So that's A. And now B. The fourth term is -11 and the 11th term is, which 11th term is 11. So we don't have the common ratio. So here we can say that if you're going to solve this, we will say that A sub 4, A sub 5, 6, 7, 8, 9, 10, and 11. So we can assume that this is the first number. And also, this is the 11th number. So a sub 1 is our first number, right? So let us assume that this is a sub 1. A1, A2, A3, A4, A5, A6, A7, A8. So you move 3 backwards, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So let us get first our common ratio. So let us try that a sub n is equal to a1 rn minus 1. So a sub n, which is 11, equals a1, which is negative 11. The r, n is, we have 8. So therefore, we have 11 equals negative 11 r raised to 7. So divide by negative 11. So r equals negative 1. R raised to 7. Right? So if that is negative 1, okay, so let us see. If we have a sub, if r is negative 1, 7th root of negative 1 is negative 1. So we have a sub n equals a1 rn minus 1. So we are looking for the first term, right? So a sub n, which is, for example, a sub 11. So 11 equals a sub 1, which is unknown, negative 1 raised to n, which is the 11th number, right? So 11th number is, that's the 11th number. So therefore, we have 11 equals a sub 1, negative 1. So therefore, a sub 1 is negative 11. It's the same thing. Let us see. A sub 1 here is negative 11, then 11, then negative. It's alternate only. So the a sub 1 is negative 11 because our r is negative 1. Okay? So let's have a continuation for tomorrow with different exercises. But you have to remember that a geometric sequence, it has a common ratio, not a common difference. All right? Common ratio, not a common difference. Those are the difference, okay? So it's already time, so let's continue that tomorrow so that you can have more examples and we can solve exercises, okay? So that's all for today. Did you record the scores, EJ, and the attendance? Okay, so let's start to recall our formula on geometric series. So what was the formula that we had? We had the a sub n is equal to a1 r n minus 1. So since we have in the geometric sequence 10, 2, 2 over 5, 2 over 25, 2 over 125, find a formula for the nth term and find the 10th term of the sequence. So let's start getting the common ratio. So we will divide the first the second to the first, the third to the second, and so on. So 2 divided by 10, also 2 over 5 divided by 2. So definitely we have 1 over 5 as the common ratio. This is also same thing. We reduce this by 1, so it is 1 over 5. Same with the rests. So our common ratio is R is 1 over 5. N is the, okay, so we are getting first the nth, the formula or the nth term. So the nth term is the unknown or the formula. So since we have that, the a sub 1 is given, which is 10. So therefore we have a, so that's a sub n is equal to 10 as a sub 1, and the common ratio is 1 over 5 raised to the power of n minus 1. So this is our formula for the first term. Letter B, we have looking for the nth term. B, the 10th term, so that's the unknown. So a sub 10 is equal to 10, 1 over 5, and 10 minus 1. So therefore, we have 10, 1 over 5 raised to 9. So what would be our value? Did you get that on your calculator? 5 raised to 9. So that is 10 over 5 raised to 9. Will you get it on your calculator? 5 times 5 times 5 times 5, or 5 to the power of 9. Michelle, what did you get? 5 raised to 9 in your calculator. So we have... Who got it? JL, Rainier, Angelo, what did you get? 5 raised to 9.
195.
1,900.
953125.
195,3. It's a lot.
Yes.
But you have to simplify it. So that is around 1,953,125, right? So reduce it by dividing it by 4. Or enter it on your calculator directly, then you can get the simplified form. So what's the simplified form then? Ten over 1,953,125. Rainier, what's the answer?
2 over 390,625.
So 2 over 300.
90,625.
Okay. So that is our 10th term.
Downs and ups. Okay.
All right? You got it. Now, in arithmetic sequence, we have sum of the series, right? So, with the common difference. Also, in geometric series, we have also sum, right? And we will be having the formula. Let us try this. Many schools set up a cell phone brigade to notify students when classes are suspended due to typhoons, flooding, or other weather disturbances. Suppose a school sets up a cell phone tree so that each student, except those in the last level of the tree, calls 3 students. Okay, so the first three levels of the three look like the one on the right. So for example, Aaron called the three students, Maricar, Bong, and Gigi. At the same time, Maricar called another three, JC, Madel, Mary, and also Bong, LV, Aloha, Ayi, and Gigi, Tino, John, and Viel. So, and those three again, they will be calling like JC, another three students that they will be calling. Okay, so same thing. So on the first one, we got definitely it's one, and then it's three, and then it will become nine. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth. So the numbers are 1, 3, 9, 27, and 81. Okay. The first three levels. Okay. So the sequence is the geometric sequence with a common ratio, right? Because 3 divided by 1 is 3. 9 divided by 3 is 3. 27 divided by 9 is 3. 81 divided by 27 is also 3. So that's why the R is 3. Okay, will you read the next question on that example on the book? If you have that one. It is said, to get the number of students in form up the 7th level, we use the formula. Okay, to the 7th level. So let us try until the 7th level of the students who will be calling 3 each, right? So we have on the 7th level, this is 1, 2, 3, 4, 5. Okay, then 6 and then 7. So on the 7th level, or let us try here first on the 6th. 1, 2, 3, 4, 5. Meaning to say that you are multiplying by 3, right? So 81 times 3, you will get 243. And let us try to get the seventh number, 7th level, which you will get a sub 1, r, and minus 1. So a sub 1, which is 1, and the r, which is 3 raised to 7 minus 1. So therefore, 1 times 3 raised to the power of 6. So what would be the value of 3 raised to the power of 6 on your calculator? Or you can say 240 multiplied by 6. So 8, 1, 24, 25, 2, 6 times 2 is 12, plus 2 is 4. Right? Is it 1,458? Check it again. 6 times 6 is 8, 1. 6 times 4 is 25. 24, then plus 125. 6 times 2 is 18 plus 2. No, it's 20. 2058. Right? 1240. It's okay. 1458. Did you check it? 1458. Check it. Justify. Okay, now that's the 7th level.
Sir, it's 729 po.
Yeah, 243. What happened? That is 7 only. 243 times 7 on times 3, right? 9, 2, 1, 3, 2. 729 only, yes. So 3 to the power 6, 729. Okay, correct? So those are the numbers until the 7th level. Now, if we will be adding those, 729. So let us get the sum. The sum until 7. So we have 1, please add it on your calculator, plus 3, plus 9, plus 27, plus 81, plus 243, and plus 729. Please add it on your calculator. Hanan, what's the final answer then?
1,093 po.
Okay, very good. 1,093. All right, 1,093. So those are the students, okay, the number of students who will be calling. So that, did you imagine that, have you heard about the pyramiding? It's like a pyramiding style that they pay money and then they will earn. That's why those who are at the top, they will be actually earning a lot. Imagine from the seventh person on the seventh level, and how many people who will be paying, right? There are 729 people who will be paying. So in that case, we don't need to do this addition. What about we have 1,000 level or 20, S sub 20? We don't need to get those numbers multiplying it by 3. But we have the formula to use. So we have this formula. Geometric series, the sum of geometric sequence is called a geometric series. So some of the first terms and terms of a geometric sequence are this. So this is the formula that we are going to use. So what do we need is only the first term and the common ratio and how many. So let us try that. S sub 7 is equal to A sub 1, which was 1, right? And 1 minus 3 raised to the power of 7 all over 1 minus the common ratio, which is 3. So let's try that. Can you check our answer? So 1 minus 3 raised to 7 is, enter it on your calculator, raised to negative 2. So what is the answer here? Rainier, what's the answer? Just a bit, I'll get my calculator. Okay, so what is the answer?
1,093 po.
1 minus 3 raised to 7 over negative 2. So it's 1,093. Is it the same on our sum on the previous one? Right. So this is the formula that you are going to use. So you have to remember another formula to be remembered. So from the start of our lesson, you have to remember all of the formulas that we have used. Okay. So that's the formula for the geometric series. Let us try the example 5, geometric series. Find the sum of the 12 terms of the geometric sequence 3, negative 9, 27, negative 8, 1, 1, 4, and 3. So we have 12 terms. This. Okay, so our formula will be on letter A, S sub n is equal to A1, 1 minus r raised to n over 1 minus r, right? So that is our formula. Easy to remember, correct? So let's start now substituting the given values. So the first thing to do is that you should get your common ratio and also your first number. Okay, so negative 9 divided by 3 is negative 3. 27 divided by negative 9 is negative 3, and so on. So therefore, we have a sub 1, which is 3, and 1 minus the r, which is negative 3 to the power of n. The n is 12. All over 1 minus negative 3. So enter it to your calculator, then you can get the value. You can directly enter that. So 3 open bracket 1 minus negative 3 to the power of 12. Okay, closed bracket over 1 minus minus 3. So the answer is negative 398,580. Justify if you got the same answer. 3 open bracket 1 minus minus 3 raised to the power of 12 over 1 minus minus 3. Did you get the same answer? All right, so let's proceed to letter B. Sarah, will you give the R on letter B? What is the value of your R on B? The common ratio. What's the R?
1/2 po.
Okay, half. All right. The first number is 1, and our N is geometric sequence. One, and N is 12 also. All right. So therefore, we have first 12 terms of the geometric sequence. So we have S sub 12 is equal to, first number is 1. 1 minus the common ratio is half raised to 12 all over 1 minus half. Okay. So therefore we have 1 minus half raised to the power of 12. And then we have 1 minus half. So what's the answer? It's approximately 2. So this is actually a geometric sequence where it is infinite, right? So even if you will have that, so the value is coming to 2. So 1 over, or 1.99999. So that is approximately 2. Even how many terms you'll get, so the answer will be 2. Right? So even if that's not 12, even if it's until 1 over 16, so it's still 2. Let us try until here. 1, 2, 3, 4, 5. So 5, let's change that to 5. So S sub 5 is equal to 1 minus half raised to 5 all over 1 minus half. So let us change the 12 to 5. 5 terms. So this is actually approaching to 2. So if that's the 12th term, it's 1.99, right? So this is approaching to 2. So next, let's go to the next one, which is our next term. Okay. So let us try to have our example 6, real life application. Okay, so the sum of the, let us add this also, A1. This is our sum that we have. Let us try the letter B. If this is not 12, so for example, this is geometric sequence which is infinite. So it never stops. So it does not determine about the value of the terms. Okay, so that's infinite. So it never ends. So let's try this formula of the infinity of the sum. A1 over 1 minus R. So if we have this, A1, which is 1, over 1 minus half. So enter it on your calculator. So 1 over 1 minus half then you will get a value which is 2. Okay? So if they did not state the value of the terms, then this is the time that you have to find this infinity. All right? A over 1 minus r, or A1 over 1 minus r. Okay? Lindsay, will you read the example 6? Example 6.
A rubber ball is dropped on a hard surface from a height of 80 feet and bounces up and down. On each rebound, it bounces up exactly one half the distance it just came down. How far will the ball have traveled if you catch it after it reaches the top of the 7th bounce?
Wow, thank you. You have a very nice voice, Lindsay. You can get a job in the like newscasting, right? So or those who are in the airport, you will try to what's it called that? Your flight number, and they are. So the bounce was 80, right? The height was 80 feet. So if the ball is already here, so it travels already 80 feet. And then it bounces up as 40, half of that previous one. So it means that this is 120, right? So once it bounces, that's the time that it will be counting. So it means to say that it travels 120 already. And then we will divide it by 2. So the next one is 60. That's the distance. The next one is 2, which is 30. And then 15. And then divide by 2, which is 7.5. So if we have that S sub n 7, which is A1, if you will consider 120, 1 minus the R, which is half, raised to 7, 1 minus R, which is half. Will you get the value in your calculator? JL, what's the value? Half.
Sir, the answer is 1,905 over 8.
Or in decimal, 1 minus half.
238.125.
So 238.125 feet.
Yes, sir.
Okay. So change the answer there. If you will be considering that on the half. But if you are going to try to check understand the problem, right? A rubber ball is trapped on a hard surface from a height of 80 feet and bounces up and down. On each rebound, it bounces up exactly one half of the distance it just came down. So this is 80 feet plus 40. So that's why it became 120. All right? So 80 plus 40, it was 60. 80 plus 40, it was 120. And then divide by 2, that's why it became 60. All right? So, and so on. Divide by 2, divide by 2. All right? So let's go to geometric means. Before we were inserting arithmetic means, right? Now we have geometric means. So in the sequence 2, 4, 8, 16, 32, the terms 4, 8, 16 are geometric means between 2 and 16. So the terms between two given terms of geometric sequence are called geometric means. So let's try. Insert two geometric means between 7 and 875. So let us try A. So 7, then we need to insert 2. Right? We are on geometric means, so we need to get the ratio, right? The common ratio. So we have A1, A2, A3, A sub 4. So meaning to say that on the A sub 4 equals A1 Rn minus 1. We need to get the common ratio. So since we have A sub 4, which is 875, A1 is 7, and then the ratio is unknown, and N is 4 minus 1, right? Because we have 4 numbers. So 875, so you divide this by 7, and then you cancel it out. So 875 divided by 7, which you will get 125, is equal to R raised to 3. So how do you get the value of R now? You need to get the cube root, right? So the cube root of 125, cube root of 100, cancel out. So R equals 5. So the common ratio is 5. So now we will multiply 5 in each. So 7 times 5 is 35. And times 5 again, which is 150, and 25 is 175. Okay? So the 2, we inserted 2, and those are 35 and 175. So you need to get the R first, then you multiply. Find the geometric mean between 7 and 63. So 7 and 63. All right. Now letter B. So let us see it again. Geometric mean. Okay. So the geometric mean is only by multiplying the two numbers. All right. So just only multiply the first and the second. So you just multiply 7 and 63 and then square it. All right. So 7 and 63. So the formula is 7 times 63 and then get the square root. So what is 7 times 63? It's 441. So the square root of 441 is 21. So when they are just 2, you just get the square root. Okay, so the geometric mean is 21. You got it? When they are just 2, just get only the product and then square root. Or it's like the proportionality. Do you have another example? No, we don't have anymore. All right.